Hello everyone, it's Mr. Kennedy here. In this video, I'm going to explain how we find the horizontal and vertical components of a vector. I'll also explain why this is useful for us. Okay, so when adding two or more vectors together, this has to be done tip to tail. So we take one of the vectors and from the end of that vector, we then add the next vector. So for example, if we have a 4-meter vector to the right, and then we add on the 3-meter vector in the upwards direction, we take the first vector, so I've chosen the 4-meter vector, and then from the end of that one, we add on the next vector, which is 3 meters, and then this vector here is now a resultant vector. This vector here has the same effect as these other two combined. And we can work out the magnitude of this, because this is a right angle, we can work out the magnitude of this vector using Pythagoras, and then the angle using trigonometry. So in this case, we have 5 meters and 37 degrees. So we can see that the 5-meter vector at an angle of 37 degrees to the horizontal is the same as the combination of the 4-meter vector to the right and the 3-meter vector up the way. So when we're working with projectiles, we call these the horizontal and the vertical components of the vector. So essentially we can split this original vector into two components, the horizontal component and the vertical component. The combination of those two would have the same effect as the original vector. So to find the horizontal and vertical components of a velocity vector v, we need to use trigonometry. So this example here, we've got this velocity v at an angle of x to the horizontal. So the horizontal component I'm going to call VH for horizontal velocity. And this is the horizontal component of the velocity. And VV is the vertical component of the velocity. So to find VH and VV, we use trigonometry. So as you know from maths, SOHCAHTOA, cos x is equal to the adjacent over the hypotenuse. So this is our angle here, x, the angle to the horizontal. So the adjacent in this situation would be VH, and the hypotenuse is V, the longest side. So that leaves us with cos x equals VH over V. And then if we rearrange that, we get take the V up to this side, we get V cos x equals VH. And just turning that equation round, we get VH equals V cos x. So to find the horizontal component of this velocity, we do V, which is the original velocity, and then multiplied by cos of the angle to the horizontal. Okay, to find the vertical component VV, we use a very similar process, but this time we use sine x from SOHCAHTOA. So sine x equals the opposite over the hypotenuse. So the opposite from this angle here would be VV, and the hypotenuse again is V. So we get sine x equals VV over V. And then if we take the V up to this side again, we get V sine x equals VV. And then just turning that equation round, we get the vertical component of velocity is equal to V sine x, where x is the angle to the horizontal and V is this original velocity vector. Let's have a look at this example then. So we have a velocity of 12 meters per second at an angle of 50 degrees to the horizontal. And what we're looking to do is find the horizontal and vertical components of this vector. So if we start off with the horizontal component, VH, VH equals V cos x, VH equals 12 cos 50, VH equals 7.7 meters per second. And then to find the vertical component, which is VV, VV equals V sine x, VV equals 12 sine 50 equals 9.2 meters per second. To summarise then, if we add together the horizontal and vertical components, we would get back to the original vector. So if we take 7.7 metres per second from the previous example, and we add on 9.2 metres per second, the vertical component from the previous example, we would add one vector to the other, and we get this resultant vector here. That resultant vector, if you use Pythagoras, comes out as 12, as we would expect, and the angle is 50 degrees from the previous question. So you can see that the horizontal and vertical components do indeed combine to give you that original vector. So the equations are then, for the horizontal component it's v cos x, and for the vertical component it's v sin x. These equations don't actually appear on the formula sheet, so it is useful to try and remember them, although you could always use trigonometry to work them out during the exam. So the way I try and remember them, this is Mr. Kennedy's tip of the video, is I use cos across. That's how I remember it for the horizontal component, and sine, think of it as being like a signpost, which is vertical, it goes up and down the way. So that's just a way I've got of remembering which one to use for which situation, so cos across. Finally, for this video, why is this important for us? So being able to find the horizontal and vertical components of a vector is useful to find out more detail about how an object actually moves. So projectiles are a really good example of this. A projectile is something which has both a horizontal component and a vertical component to its velocity. So if we take the International Space Station here, for example, the International Space Station is a projectile. It has a constant horizontal velocity, but it's also constantly accelerating vertically as it falls around the Earth. Scientists can use the information about the horizontal motion and the vertical motion to predict the space station's path and to make adjustments to its altitude. I hope this video has been useful for you. Thank you.